Everybody, welcome to CRDs. Let's talk about versioning and releases. So, before I get started, I did want to ask, so who's used CRDs already? Hands up. Okay, that's reassuring. Okay, who's designed their own CRD? Okay, even more reassuring. Excellent. Okay, so I'm gonna. I wanted to make sure that this is accessible to, because it's a maintainer summit now, not just contributor summit. So I'm going to run through some stuff about making changes and how to do that safely, because that'll help with explaining some of the reasons why some of the versioning stuff is harder than it might seem. Okay, so to get started, making API changes is hard, and the core Kubernetes APIs have a lot of best practices around making API changes and how to roll these out safely, but CRDs don't have as much yet, being the operative word here. So I want to classify CRD deployments into two types here, an implementation-specific one and an upstream one. Now the implementation-specific one is when you deploy it alongside and have it tightly coupled to a controller implementation. So those examples are like Cilium's various CRDs, Istio's ones, Linkerd's ones, Contour ones. Those are all ones that I've actually looked at closely. So there's plenty of other ones, but those are the ones I know the best. It makes the versioning much simpler because it's tightly coupled. There's a couple of examples of that I'll talk about in a minute. Upstream ones only sort of started existing basically 5 years ago when we started Gateway API. There's a few other ones now. I see the admin network policy folk here. Hi. And I mean, technically cluster API is kind of in this sort of boat as well. But the biggest thing here is that all of these are developed by the community as a specification rather than the controller necessarily being included. But that does make versioning significantly more complex, and that's what I wanted to talk about. So let's just go through important types of CRD versions. We got the API version. That's the V1 Alpha 1 that we all know and love. That's in the API version field. Now, there's also what I like to call the schema version, which is like the version of the schema, because you don't necessarily need to bump the API version field to change the schema. There are allowable changes. They need to be round-trippable. It's unusual that the schema version gets encoded anywhere. We do in Gateway API in a label for exactly this sort of reason. And for core APIs though, generally the Kubernetes version is the schema version. So that means that when you bump a Kubernetes release, it's allowable to make round-trippable changes, and so effectively the schema version is the Kubernetes version. And then very importantly, there's also the storage version, which is the version that gets persisted to etcd. A lot of the funkiness about making changes comes down to being able to safely do storage version conversion. That's an awkward phrase, but so being able to safely convert between different versions to whatever version you need to store. And so that's where the round-trippable requirements come from. So, okay, there's a bunch of text on this slide. I wanted to include all of the points here so that everyone can see them. But the key one, it's basically, a lot of it is common sense stuff, but the key one is that your changes must be round-trippable. I've used that word a lot. I am going to explain it in just a minute. This is like one of the key things is the round-trippable, but all of those things, the reason that that's a key thing is all of the stuff that's around that, right? Like that, API clients can safely make a change in one version and support multiple versions and then things like that, right? So. Okay, here's an example. So this is a very simple CRD. This is actually the one that's in the API changes docs. So this is a throbber, and it has a width and a params field. Now, height and a params field. The width is hard-coded to 10 in the controller. Like the controller just assumes that the width is always 10. So at some point, we want to increment this. We want to change it. So what we do is we say, okay, we're going to make a change. Schema version is now 1.1. We've added a new width field that defaults to 10. So that change itself, because it's got a default and it's an optional field, that width field is optional. So the object is round-trippable. So the API change itself is round trippable because it's possible to have an object that is round trippable. This object is also round trippable because there's no change in functionality between having a width of 10 explicitly specified and having a width of 10 implicitly specified by the controller. Right? So in this case, this specific object is round trippable. However, if you set the width to 11, this specific object is no longer round trippable because when it goes back, if you take this object, roll it back to the version before, the width gets set to 10, and then you roll it forward, and the width will be defaulted to 10 because the width will go away, right? So you can have an API change be round trippable, but if you use the new functionality, then that object is not round trippable anymore, right? So this is, again, one of the reasons why this is complicated and the storage version is very important. A lot of that depends on the storage version that's used. In this case, you were using Schema v1 CRDs as the storage version, then it's all good. But again, anyway, I don't want to go into that. So here's another example. So this is using a 1.1 schema. We've got a single param field. I put a nonsense param in there. Okay, so now we change the schema version 1.2, and we pluralize this to a params field. So this change is actually round trippable as long as you have a conversion thing that will take that first value of the params field and copy it back to the singular param field in the previous release. So this specific object is round trippable as long as that is the case. However, once you add a second param to the params field, the object is no longer round trippable because you can't round trip it, right? So I've gone on and on about this, but this is like the key thing that separates a sort of a safe to add API change that does not require an API rev from one that does. Is that if it is not possible at all to have the API to have an object be round trippable, then it's not a safe change to make. This is the quickest way that I've tried to sort of. Rule of thumb this for myself is to be able to use that rubric to have a guess at, to get me started. I spend a lot of time doing API reviews these days. Okay, so in the core, we have access to feature flags. And so you can use feature flags to sort of stop people from using code that they're not expecting to, but at the same time to allow people who are expecting or wanting to try out that code to opt into it. Right? So again, that's what feature flag means. But traditional feature flags aren't possible for CRDs because there's a single instance of the CRD, and there's no way to make fields defined but not usable, right, in a CRD. So again, this is one where if you have an implementation-specific CRD, then you can build your feature flag straight into the controller that manages that CRD, right? So, for Cilium, if we add a field to one of our objects that is a safe field, a round trippable field, we can add a feature flag that says use this field to Cilium, and then that will mean that if you don't turn that feature flag on, then the field, if you set the field, nothing will happen, right? And so that makes it safe. But for upstream CRDs, it's much harder to do a feature flag because you're decoupling the API spec from the controller implementation. The specification needs a way to tell controllers which fields are experimental or which fields are, can be in use, and you don't have a way to do that. So Gateway API has a solution. We're not claiming it's the best solution, but we have a solution. We are 100% sure it's not the best solution because we're improving on it already. But so I wanted to walk everybody through this, and I'll be honest, I have specifically kept this talk not too long because I would really like to have some time to have a discussion about this as well, because I think there's a lot that is sort of hidden about some of this stuff, and a lot that it's really important to talk about. So to go through how we approximate feature flags in Gateway API. So in Gateway API, we have two options for installing the specification. There's two versions of the install YAMLs. There's the standard ones, which includes only stable objects and stable fields within those stable objects. And then experimental, which includes all fields, including the experimental fields, the ones we're not sure are stable yet, and experimental objects as well. So we could call these channels. So there's the standard channel and the experimental channel. As I said here, that effectively gives you one feature flag. Like, are you using experimental or not? Right? There's no finer grained control than, are you doing experimental? Are you allowing experimental stuff, or are you not? And so, there's a bunch of pros here, which is why we're doing it this way, right? Like, a cluster owner can decide if they want standard or experimental. The implementations generally can use a single set of Go code to handle both cases because they're the same objects and it's the same Go types underlying both of these things. In some of them, when you're using standard, there's a bunch of fields that just will never be populated because they're not present in the CRD definition. So when your code is reading them, you don't have to worry about. You can handle them in the experimental case, and then the standard case is already handled. And so that's why implementations don't need to make code changes for the happy path of features moving without change from experimental to standard, because you build the support in experimental, then we add the conformance tests and everything that make sure we're happy that that's how it should work, and your implementation already supports it in experimental, then the field moves to standard, your implementation has nothing to change, right? So the reason it's like this is because everybody who's been working on a specification for the last 5 years is also, basically everyone is also a controller implementer, and so we all pick the things that were easiest for us first, right? The other thing that's kind of a nice feature in some ways is that users don't need to change their objects, right? Like, so you can take a HTTP route that's using, budgeted retries, which is one of the newer features that is currently in experimental, and you can just apply that HTTP route, and if it's experimental in the cluster, then the feature will work, and if it's not, it won't. But then that comes to a con that I'll get to in a minute as well. But also, users can just start using the new fields when they're added to either experimental or standard, right? So as long as you're running experimental in your cluster, if you move from v1.2 experimental to v1.3 experimental, then any new fields that were added in experimental, you can start using them and expect them to be persisted correctly to etcd. Whether or not your implementation supports them is another story, but the specification-wise, they're supported and the field will be saved. It's always safe to move from standard to experimental as long as you're not downgrading. So if you move from version 1.3 standard to version 1.3 experimental, that is a completely safe operation because experimental is a superset of standard, right? So, okay, but that leads us to the big caveat, which is it's never safe. We can't guarantee that it's safe to go from experimental to standard because we might make mistakes. Some things in experimental might break, like we might have to break them. So we can't guarantee that within a same version, if you're going from 1.3 experimental to 1.3 standard, it's not safe because your users might be using those functions, and those may not be round trippable, and so they might lose functionality. So that creates more caveats. Managed Kubernetes providers, for very good reasons, don't want to allow experimental because they don't want users using features that might break or change. And having multiple controllers install their own version of Gateway API CRDs is also unsafe because if you've got controller 1 wanting version 1.2 and controller 2 wanting version 1.3, and they're both trying to reconcile those definitions and make sure that they meet their requirements, then you have both controllers are going to fight over the CRD definition, which is really bad. It's also very difficult for users to tell what options are supported in the CRDs without actually just putting them in and seeing what happens, which seems like not ideal to me. And also, leading back to what I said before, it's also very difficult for users to tell what options are supported by implementations. Now, we've done some other stuff about adding supported features to a gateway class that's helping with this a little bit, but again, that's not a standard thing. It's very difficult you've got to do a lot of design to make that happen. Okay, so that means that we've got a few types of changes in Gateway API. So we've got promoting a field or resource from experimental to standard. This is the good one. This is the one we want to have happen. This is the happy path. Everybody's happy in this case. Feature was working in experimental. We got it right. We promoted it to standard. There's enough conformance tests. Everything is great. There's also adding a new kind or resource that starts out as experimental. So, hey, we're adding a new object. We're not 100% sure we got it right yet. Maybe we might need to make changes, so we need to add this whole new thing. Because we may make breaking API changes along the way, we've got to be really careful about this. Now, we try not to make breaking API changes, but the one thing you can know about API design or about any software is you're going to make mistakes. And so your system has to allow for you to make mistakes. The last one that's the scariest one is adding a new experimental field to a resource that itself is standard. So there needs to be a way for example, in the Gateway API, if we want to add a new field to the Gateway object, there needs to be a way for us to safely do that and to be able to communicate to users that this new field is still experimental and we haven't finalized the design yet. And there's so many things that can go wrong if you've made a mistake, if you need to change the field, if you need to, there's a lot of changes that are breaking changes that can really cause problems here. And it also can lead to what some folks call the dead fields problem, where you add a new field in experimental, and then if you roll back, sometimes the field will be persisted into etcd until you touch it with the new schema, and then if you re-enable it later, then you'll read that value out of etcd and it'll be deserialized correctly. So sometimes it's very possible to have config saved into etcd that will spring back out of nowhere later without the user necessarily knowing that that's what would happen. So again, really important stuff to make sure we get this right. So what are we trying to do better? Well, the first one that we are doing in the current version of Gateway API is that we're changing how we add new experimental objects, whole objects. We are going back to using the xkates.io API group for these experimental objects, and we're also prefixing the name with an X, right? So unfortunately, this means all of us who write implementations have a lot more work to do, because now you've got to import a whole new module, you've got to use different types, and then when this thing moves to standard, you're going to have to refactor all of that and change it over to the new types. Kind of sucks because there's a lot of code churn for no functional change, but and the other thing that kind of sucks is that for users, they can't just use the same object, right? They can't take an X listener set once it moves to standard and just apply it and have it just work. But that's kind of what we want. Like, this is a case where we're adding friction because we want users to have to take a definite action to start using the standard thing as opposed to the experimental thing. And so it's the same for implementations. We want implementations to be deliberate about what they're supporting in experimental and what they're not. But the big win here is that the same cluster can now safely run all of the standard channel objects and the new experimental objects in the same cluster. And if you don't want to run the new experimental objects, or you want to remove them, you just delete just the experimental objects, and boom, safely removed. So there's a safe transition from experimental back to standard. That's the sort of the key thing that we're aiming for. Okay, so yeah, should you do this? If you were writing implementation-specific CRDs, no, this is way too much overhead. You should not bother, right? Like, don't do this unless you're writing an upstream CRD where you really need multiple controllers to be able to coordinate using the same specification, right? So it's a relatively limited set of people who really need to do this sort of stuff yet, but the idea here is for me to sort of tell everybody now, so that those of us who do need to do it, we can all be on the same page. And then as more people start doing the same sorts of stuff that we've been doing in Gateway API for a while, then it will make it easier. Hopefully we can make it easier for people to sort of know about the sorts of stuff that can happen. Okay, future work. We are looking at trying out using validating emission policy for existing standard objects to prevent use of experimental fields. So what this looks like to me is that at some point we might have the same YAML being installed in both the standard and experimental cases with all of the experimental fields included. But we also, as part of that install, include a bunch of validating admission policies that if you try to set any of those fields, the validating admission policies will like, no, you can't, you're running the standard channel, we're not going to let you set that. I have a couple of concerns that I don't like the stable thing being reliant on the presence of something rather than the absence of an allowing thing. If you see what I'm saying, like I don't like that. If you have to have a thing there to be on standard rather than not having a thing there means you're on standard. But we're going to have to wait and see how that goes. We had to wait for validating emission policy to be supported on all our supported Kubernetes versions. So because we're trailing 5 versions, we had to wait. And so I think the other thing that will help with is that dead fields problem you can stop people from being able to write fields to those things. It doesn't stop the problem where those fields have had stuff written into them into the data store and then you read them out and it's a surprise later. But we can't boil the ocean here. Like improving this thing one step at a time is better than not improving it at all. So yeah. that's everything I needed to say to you all. And the most important thing is, yeah, like, does anyone have questions about this stuff? I'm happy to roll back and talk more about round tripability or anything like that. Or if people want to talk more about ideas other people have about how we can solve some of these problems, then I'd love to do that. So, thank you. But yeah, hit us with the questions. I think there is a mic there if you want to ask questions there. Thank you. Yeah.
Can you go to the slide where you had the X prefix coming in for the group?
This one?
Yeah, I get why we do this, but you were very explicit when you said this is exactly what we want. Isn't it an overhead for the implementations, like you said? So have you considered the fact that it's going to not exactly motivate implementations to adapt the API? I mean, I know Gateway API has like 35 plus implementations. It's not a problem, but it feels like you're putting the overhead on the implementations. But then you seem to be very sure that that's exactly what you want to do, which is the whole goal here.
So it's a really good question. Thank you. So yeah, we are putting work on implementations here, and to be honest, like the trade-off, we feel like the trade-off is worth it. Putting the extra effort on the implementations does mean the implementations need to do extra work, but and some implementations may choose to stop doing the extra work, right? Like that's up to them, right? Like, but to me, the way this goes is if you're not going to put in the work to try out the experimental stuff, then you can't come and whinge at me when you don't like how it's designed, right? Like, you know, if you're not going to supply the feedback, then you can't complain about the design, right? So like, that's if you choose not to spend resources on implementing the experimental stuff, that's your choice. But like, that means that the decisions about the design may be made without your input.
And just to follow up, the second aspect is we assume that, well, the hope is that the experimental fields are never used in production, but people often want that, right? So are we considering a migration path, or we're just putting that on the implementation completely where they have to?
So I think ideally we would like to be able to give people tooling that will help us aid in migration, preferably with warnings for if you're using something that we broke. And we have Ingress to Gateway as well that is specifically designed to do this sort of conversion. So that's the idea, is that hopefully we can provide some tooling to help with that sort of thing as well. Like, I'm aware that I'm very aware, I'm going to have to do this for Cilium as well. So like, I'm very aware that it sucks, right? Like, but Rob and I and the other maintainers are worried that the implicit costs we've been pushing out to everybody else could suck even more in the future, right? Like, and so this is like one of those cases where, as maintainers, we are best suited to accept the costs and understand what the costs are, rather than pushing this externality out to users who might not necessarily be aware of it. And so, like, I completely get it sucks, but like, we're trying to be mindful of who has to pay the suckage cost.
Hey, so first of all, thanks for the talk. So I came to the talk and I expected to see conversion webhooks, kube builder generation, promotion, alpha, beta, gamma, stable, and I didn't see any of these things. Is that not in there? And if not, why you chose this path versus what Kube and most of the ecosystem is already doing with promotion, versioning, and conversions?
So we try. Like, rolling the API version is a huge change that also requires a lot of change both from users and from the implementations. And so, and also running a conversion webhook is also a lot of operational effort that when you're a reasonably big project where you've got a lot of implementations, we didn't want to have to force implementations to run a conversion webhook to be able to do this. We're trying to avoid having to force people to run something to do the conversion. Again, when you're doing this in the core, it's fine because you've got the API server there and the conversion webhooks can run inside that, and you don't have to have the infrastructure to like deploy the certs, to securely talk with the conversion webhook, to run the conversion webhook as a thing, to be a deployable thing that you need to maintain and check for CVEs and all that sort of stuff. And so we're trying to avoid the overhead in the Gateway API project of doing that by moving towards things that are built into the CRD spec as much as possible, like Cell and like using validating emission policies and stuff like that.
So sorry, but I'm devil's advocate. You mentioned certificates running webhooks. Yes, that's a problem. Was this approach to solve it in a core, like to make it easier to run the webhooks? Because I'm conscious as a community, we sometimes we see a problem in a core, we see a problem somewhere, and instead of working towards making it easier, we jump to the easier solution, which, looking from the side, looks a bit hacky from what was the original intent in this stuff. And that's...
Yeah, I mean, like I said, I think part of the rolling the API version was not intended. I don't think anyone really thought that it would be as big a deal as it's turned out to be. Like, rolling an API version is a really big deal for everyone who uses it, both implementers and users. And so in the core, it's not so big a deal because it's all, again, it's the implementation specific thing, right? Like, you've got the controllers that reconcile your thing are tightly coupled to the definition of the thing, and so it's way easier. But when you're doing this sort of specification thing where I don't have control over Istio's implementation of this thing, the only thing I have control over is what the specification says. And so, forcing anyone who wants to use Gateway API to run a webhook to be able to do it is sort of counter to the idea of it being only a specification. And so that's why, one of the reasons why we've sort of we've shifted in this way and done it. We did have a webhook for a while, and we had heaps of problems with it, and it was very difficult to keep up to date, and a lot of people just didn't run it. A lot of people just chose not to run it, and that meant that they were completely vulnerable to lots of weird stuff about version conversion, and that's even worse. So like, we're trying to make it so that there's less stuff to run, so that we actually have people comply and do this. And it's built in that they have to do the stuff. So I think it's all completely fair things. We have talked about them though, I promise. Yeah. Thanks.
Yeah, just to provide a little bit more context. Like Nick, you've done an amazing job here. But one of the things, my perspective on this is we are trying to make stable channel, standard channel, as stable as it possibly can be. And there's a lot of focus, understandably, on how unstable experimental channel is, right? Because we've added these X resources, we've done all this stuff, but part of the contract of using experimental channel is there are going to be breaking non-convertible changes in that channel. And so using conversion webhooks here, there, whatever, I mean, the whole premise is that using experimental channel is inherently unstable. It's not somewhere you should live long term. And part of the confusion about what we were doing up until now is that you felt like you were using something stable because it said gateway in the name, it had the same, everything felt the same. You could forget that what you were actually using was a very experimental API surface. Yeah. Because we made it so easy. So this is actually adding a little bit more friction in that path. The other thing I would say to Surya's thing, there are at least some implementations where this will actually allow them to support experimental channel. Not naming any names, but so
it's going to make your life easier. Let's say that, Rob. Yeah.
So it's not. There will be some it will be harder for sure, but there are others that will hopefully benefit from this as well. And then final thing, I promise. Shameless plug. I think all of this work is required if we want to install these CRDs by default in Kubernetes. If you have an opinion about that, we have an unconference session at 4.
Yes,
today?
at 4. Yeah.
Yeah. Okay.
So Rob and I are leading an unconference session about that at 4 p.m. So yes, please come to that and have more chats about this sort of thing. Keith.
Hey, so I've got mixed feelings about this, as I'm sure many people do. I guess my question/concern is sort of this mirror dimension problem where we look at the ecosystem of not just gateway API implementations, but also gateway API integrations with things like Argo CD, or Cert Manager, or not Argo CD, Argo Rollouts and Cert Manager, and all these various things that want to target gateway resources. What if they decide to only target experimental? What if they decide to only target standard? And then as implementation, that creates this combinatorics thing where, oh, my implementation supports experimental, but not this integration, and so now I can't use it at all. And that sort of net new friction that might not have existed at all, period, with the old way. So I guess, what's the mitigation for that scenario?
I mean, it's a really great question. I don't know yet is the answer. I think we're going to have to see how it goes. Again, part of this is literally experimenting with experimental, right? Like, we are trying this out because we know that we have problems with the current approach. We want to be able to try something. This is sort of the minimum viable change that we could come up with that while it is impactful and it does require people to do things, it's like, we could change our minds and go back from this, right? Like, it is fixable, right? Like, so, but we can't leave it as things are. Like, the current state is not sustainable, so we need to do like a thing, and this is the best, least footprint thing that we've been able to come up with. If people have really strong feelings about it and want to come up with a better solution, please, I'd be happy to do it if we could have another solution that didn't have this big list of caveats. I'm pretty confident that anything you come up with will have as many caveats as not more, but that doesn't mean I'm 100% right. Like, I would love to be proven wrong on that point. So, yeah, thanks, Keith.
Hey, Nick.
Yeah, hey.
Awesome talk, thank you.
Thank you.
Going to go for, I'm not a specialist here, this is just my opinion. It seems that this problem goes to the source of it. It's like the etcd cannot be storing multiple versions of the same CRD, right? Did you consider also tackling that as the source of the problem and making it work? Like,
it is absolutely a thing that people could do. We are kind of trying to solve this problem in a shorter time frame than that would require. So that's why one of the other reasons why we're doing stuff that looks hacky is that a lot of the stuff that's not hacky would require substantial, kept requiring changes to core Kubernetes. That would mean that, like, it's maybe a year to get your KEP done, and then like a long tail of a few years before you can actually use it in Gateway API because of the 5 versions thing. And so we're trying to do things a little bit faster than that and try things out, with the option to have that in our back pocket. So again, if other people want to look at like how to store multiple versions in etcd, like, please go ahead. Like, I'd love to use that, but I don't have the bandwidth to be able to put towards that, and that's really what it comes down to here. So really great question. Thanks, man.
Thank you.
Thanks, Nick. Quick question. What does it mean about, let's say we introduced a new API version right now, and it will probably go under x-KHIO.
Yep.
But what is the, are we doing it v1 alpha 1? Are we doing it v1? Like, what's going to be the semantics there?
So I think we're using v1 alpha 1 for the X resources now. With the intent being that when we move them to standard, they'll go from v1 alpha 1 in X to
v1.
V1. Yeah.
So like they're like basically for new resources, like no meaning for v1 alpha 1 in the standard group.
Yeah, exactly right. And so the intent here, in the ideal state, eventually standard contains only v1 resources, right? Like, that's it. And that's what we want to head towards, so that people can safely say, I've got standard installed in my cluster. That's all I need to worry about, right? Like, there's no breaking changes ever to standard.
Got it. And for the things that are only v1 right now, are we gonna are we planning to duplicate them to the x-IO for experimental features?
We talked a lot about it, but no. We went backwards and forwards, but yeah, no, because we didn't want people to have to copy their entire config to be able to buy into experimental, right? So it does mean that there's going to be sharp edges for experimental. Like for listener set, listener set is a thing that lets you like break out so Gateway has an array of listeners. A listener set is a thing that lets you take that array of listeners and put it in separate objects. And so targeting that to a gateway, Gateway requires you have at least one listener, right? So practically you're going to have a dummy listener that needs to be on your gateway, but that's because we don't want to change stable gateway like to make a required field optional, because that's a really big change that has a lot of downstream implications. So this is another place where trying out experimental is going to have like some sharp edges. But again, we see the sharp edges as being like, well, it's experimental, like, sorry, but, pardon our dust.
Quick follow-up on that.
Yeah.
Do you rev alpha versions of the X-Cates if you drop a field?
If we make it, so we haven't had to yet, but like, yes, if we make a incompatible change, then yeah, like I would assume that we would be revving. Yeah. So we've gone up to v1 alpha 3 on the existing sort of resources. So yes, we will plan to do that. Not 100% sure if we'll be like how we'll be handling this. If we'll be revving it for some objects and others. Like a lot of this is TBD, right? Like we've literally only done this for a couple of things like last week. So this isn't hot off the press. No worries, Leo.
For fields on existing objects, is there any plan? Like it seems the validating admission is pretty minimal and probably likely to be ignored. Like would you consider having to recreate an X object on an existing object that has a new field or a changed field?
Yeah, so we talked about it again. We've left that sort of experimental objects on standard experimental fields on standard objects. We know it's a problem, but we're like, it's a really hard problem, so like it's a future Nick problem. Like, you know, like we haven't really thought too much about it yet because we want to try this out for the new objects and see how we go. Again, in the interest of not changing too much too fast and going down, you know, we want to try things out and see if they work first. But yeah, like it is 100%, it's probably the biggest problem we have, right? Like adding experimental fields to standard objects is deeply scary, but you know, sometimes you gotta, right? Like for us to be able to do listener set properly, you know, we will need to add fields to Gateway to do it. But so we can add fields to, you know, we will basically, the thing we have tried to do is that whatever we do is no worse than what exists today, right? And so today, if we wanted to add a field to Gateway, then that new field gets included in the experimental install YAMLs for that standard resource. And if you install the standard ones, then this field is not included and you have the dead fields problem and all that stuff. But that's no change from how it exists today. So it's like, well, at least we haven't made things worse, right? So that's the sort of the, at least we haven't made things worse is where we're aiming for.
That's fair. And then maybe this is more for the unconference later, but when you're considering basically blessing CRDs, have you thought about the pathway of making sure that you're not introducing new risk or leading people to maybe trust or use something that they don't fully understand? Or, I mean, Kubernetes has a statement broadly of not being secure by default, but how are we going to make sure that we're not insecure by default either?
Yeah, yeah. So yes, definitely we have been thinking about it. I do want to talk about it more, but that other session is probably the one to do. Mike?
Yeah, so some of the problems here seem like they're tooling solvable, like specifically the X prefix on like X listener set, that's to work around having kubectl get listener set return only from one API group. That's like a thing that we could potentially solve in tooling.
Yep, and so again, like I'd be very happy to solve this in tooling and be able to throw this rule away, but today it's not solved and we wanted to be able to do this today, so we dealt with the things we had today and put an X in front of it.
Yep, so going from that though, I'm really curious about like the interop between standard and experimental. So one of the earlier ideas when we were talking about previously having an entire mirror universe where everything is X dash, was to have like X listener set can only attach to an X gateway, it can only be referenced by X HTTP routes. How are we thinking about it now with HTTP route potentially attaching to an X listener set and X listener set potentially attaching to a regular gateway? Especially for implementations. Yeah,
I mean, so like I'm getting the winded up, so I need to answer this one quickly. But the intent here is that that if you're because the way parent refs work, if you are referring to a thing that you don't support, an X listener set, then just don't do anything with it, right? Like just ignore it. That's the in the same way that if you are referring to a service and you don't support Gamma, then just ignore it. That's what we expect. So that's sort of the way that we hope to deal with that for now. Okay, so thank you for all the questions, everyone. That was exactly what I was hoping for. Thanks again for listening to me ramble. And yeah, like feel free to come and talk to me more about this later or at the 4 p.m. session. Thanks very much.